Hi folks, welcome back to Math with Captain Rod. I just wanted to start that one out with a little bit of mood music here. I'm making this video here to help you out with section 4.4, which is basically about applications of quadratic equations. So when you work on these problems, here's what I want you to do. You read the problem, and then I want you to classify it as one of three types. As I look through this page here, some of these problems are distance rate problems. I don't mean this to be like distance divided by rate. I mean this like, problems about distances and speeds and things like this. A boat goes, so fast with the wind, so fast against the wind, that type of thing. Some of these are work problems. People painting houses, or problems about printers printing out things, or just about anything you could think of. Pumps filling pools or draining pools, right? And then third, I just put other here, other classifications of problems, things that are about geometry, circles, squares, triangles. Some of these are about numbers, and almost anything else could show up. But the big thing I see on this page, we have distance rate problems, we have some work problems, and then we have other stuff. So when you are looking at these, or when you're on your test, I want you to very actively or deliberately classify, ask yourself, what type of problem am I looking at? Am I looking at a distance rate problem? Am I looking at a work problem? Or am I looking at something else, maybe a geometry problem or a problem about numbers? Right? Now we're going to talk about these things individually. So these distance rate problems, right? You're pretty much always going to be working from the following equation here, right? The distance traveled is equal to rate times time. Right, that's the basic formula you're going to use to set up equations for any of these problems. Make sure that you very clearly define your variable. Things like, for example, maybe let R equal something like rate of boat in still water. Now again, I just write this down as an example. This is going to vary case by case. And after you define your variable, see if you can describe other things with it. For example, if the boat's going a rate R in still water, it's going to go maybe R plus 10 mile per hour with the current, or R minus 10 mile per hour against the current, things like that. Then set up an equation. These problems will typically look something like, this boat can go, like 500 miles in 20 hours or something with the current. That would look something like this. Right? Boat, the distance traveled 500 equals rate with the current times time. And then it'll usually give you something like it can travel against the current in a certain amount of time. Write a second equation typically with these problems. Then you end up with kind of like two equations, two unknowns. So any problem that you classify like this, a distance rate problem, write this formula down, very clearly define a variable. Make sure that once you define a variable, see if you can define other things like, if this is the rate in still water, rate plus 10 mile per hour with the current, rate minus 10 mile per hour against the current, that kind of thing. Again, the 10, this could vary with problem. Then use this formula to set up as many equations as you can to solve it, right? These work problems, right? Anything that you identify as a work problem, like, Joe paints a house in 6 hours, or a printer can spit out 100 copies in 5 minutes, or a pump can drain a pool in 2 days. Anything like that, you're going to work on you're going to use the following equation here, that jobs completed is equal to rate times time. Right? Kind of examples of what I mean here. Imagine that we have a painter that can paint 3 houses per week. 3 houses per week. Then how many jobs or how many houses could he paint in 5 weeks? Well, your jobs completed then would be your 3 houses per week times 5 weeks. Right, and you'll notice these cancel, and you're going to get 15 houses. He would complete 15 houses. So anything that starts with these work problems, write this equation out. Okay. Then the next thing I want you to do is start thinking about what type of equations can I write for this. Whoops, not what I wanted to do there. Oh, there we go. I'll just guess we'll just do it this way. All right, so usually you have to, not usually, you will almost always have to define some sort of unknown. These problems typically look something like, oh, Bob can paint a house in 5 hours. Well, if Bob can paint a house in 5 hours, then Bob's rate is 1/5 house per hour. And, if another painter can paint a house in maybe a similar amount of time, maybe 3 hours, the rate of the second painter, I'll put rate 2 here, would be, what did I say, 3 hours? 1/3 house per hour. So start thinking about what the rates look like depending on what you're given in the problem. And then the rate together is the sum of the two, right? The total rate working together would equal 1/5 plus 1/3. And again, this would have units of house per hour in my little example. I'm going to leave this off. Now, setting up the equations, they'll typically say something like, like how long can they paint it together? So you're going to use this equation here if it were worded like that. And your jobs completed in my example would be 1. And then for the rate, you would use this, and then times time. All right. And again, I'm going to make another video for examples, so don't worry about that right now. I'm just kind of giving you an idea of how to get started with these. All right, the ones that you kind of classify as other here, or at least what I classified as other. Okay. If it's a problem about geometry, write that geometry out. Some of these say something about a rectangle. Maybe, farmer's making a rectangular pen for some sheep or something, right? And anytime you deal with any geometry, label it. Like, oh, this is some sort of length, and this is some sort of width. Or you could call them X and Y. You can call them anything you want. Or maybe we're dealing with a triangle. If you're dealing with a triangle, draw the triangle and label it. Maybe length, width, etc. All right. Then it's about what type of equations can you write. Well, most of these problems in this area have to do with perimeter and geometry, or I'm sorry, perimeter and area. In this particular problem right here, the perimeter would be, you see I have 2 of these and 2 of these, 2L plus 2W. And a lot of times they have something to do with area. In this case, the area would be L times W. All right. Over here, if I wanted to write an equation maybe for the perimeter of the triangle, we would need to calculate the side. Well, that can be done by Pythagorean theorem. Square root of L squared plus W squared. Hopefully you're familiar with that. In this case, if I had to write an equation for perimeter, it would be L plus W plus the square root of L squared plus W squared. Or if I had to write an equation for the area is 1/2 L times W. And these could be any geometries. So again, anything that you classify as other, any problem that's not one of these, not one of these, it could be geometry. If it is, draw the geometries that you're talking about and label them. And then if the problem is about perimeter and area, use your picture to write the equations. And then what happens is when you go to solve for something, you'll end up with a quadratic. If the problem is about numbers, clearly define your unknown, like let x equal, some, I'll just put Sn here for some number. And then you have to read carefully the rest of the equation for other details, like if it says something like, oh, I'm looking at 2 consecutive numbers. Well, if one of them's x, the other would be x plus 1. And then, oh, their product is 62 or something. Well, then you'd say, okay, this times this equals 62. Other things to watch for. You might see something like 2 consecutive odd numbers, right? Well, if I let x equal the first number, the next one would be x plus 2 if they're both being odd, or if they're both even, right? Then what the equation looks like is going to depend on the wording of the problem. So that's what I want you to do with every problem, is read it and classify it as either a distant rate problem, a work problem, or maybe one of these two, or perhaps something else could show up. Then make sure you write out whatever formula you can if appropriate. So if it's a distance rate problem, I want you to write this out first thing. Or if it's a work problem, write this out. Or if it's one of these problems, draw the geometries, right? And draw and label the geometries. Now, if the geometries are not given, like I don't know the length, I don't know the width, it still has to be something, so just label it like L and W and move on, right? So this video is just kind of meant to be an overview of how to get started with these. I'm going to make other ones here now for, with some actual examples, all right? Hope that this helps. Have a great day.